All right, you guys, this is for mass wasting, and this is kind of a neat thing. One of my favorite physics labs, we walked in and there were these 2x6 planks and bricks and things like that, and what we did was we kind of figured out the coefficient of friction. And if you look here we have a slope, and here we have maybe a brick sitting on it. And you say, okay, is that brick going to slide or is it going to stay put? And that depends on gravity. Now, everybody knows gravity. Gravity is what holds us towards the center of the earth. So that's this big blue line right here. And gravity actually can be broken down into its two component vectors, the normal force of gravity, which holds us to the surface. Sorry, my dog is freaking out. And the shear force of gravity that is trying to slide us down the hill. Now, you guys, in vector physics, vector physics is kind of cool, the size of the arrow matters. And if you look here, the green arrow is longer. What's kind of cool, you guys, I know this isn't really physics and this is not part of the test, but if you add the green and the red, it does make the blue. So notice that the length kind of matters, and so I can put it perpendicular to the Earth's surface, but only as far as this line, and I can put it parallel to the Earth's surface, but only as far as that line, because the length matters. And it should be pretty obvious that the green arrow is longer than the red arrow. Because the green arrow is longer, that block will stay put. All right, down here though, I've just went ahead and made this hillside a lot steeper. And that blue line is supposed to be exactly the same, the force of gravity that's pulling it down towards the center of the earth. But when I make those two vectors, what you'll notice is now the red vector, the shear force of gravity, is longer than the normal force of gravity. So that will move down slope. Okay. Now it gets a lot more complicated than that, but it's just kind of cool when you think about it. Now, I wanted to go ahead and draw a couple of pictures for you. And again, I'm not an artist and neither do you need to be. And what I want to do is talk about the difference between a block glide or transitional slide and a slump and a rotational slide, because I will be asking you guys to draw these. Now, block glides are what I grew up with. You guys, the cliffs of Santa Barbara, here's the ocean, okay? And here are the cliffs of Santa Barbara. And so here are the hillsides, and they are pretty steeply sloped. Now, they're layered sedimentary rocks that are tilted, and these lines right here represent the bedding planes. Now, what happens is that the waves undercut the bedding planes, or undercut the different layers, and so this is going to move downslope parallel to the surface, because these bedding planes are what kind of determines where the surface is. So a block glide is where the break is parallel to the surface, and this material will move downslope as a cohesive slump, and obviously it can break up when it reaches the bottom. Now, the difference between that and a slump or a rotational slide is we don't have the obvious bedding plane. Now, in a dotted line, I have just drawn what the slope used to look like. And with a slump, you've got a curved or arcuate surface. Okay, the break is going to have a curved surface. And it's just like a lazy boy recliner. All we're going to do is basically take this block right here, this slice of melon, and just rotate it. Okay, so it has slid down, head down, toe out. Okay, just like your lazy boy recliner. You pull that little stick, your head goes down, your feet go out. And so again, curved surface here, a curved break. And here the break is parallel to the surface. And it's pretty much always along those bedding planes. All right, so watch the cool video on the Tennessee rock slide, because that's pretty much a block glide. All right, the last thing I wanted to talk to you about is creep. And creep is the most widespread type of mass wasting. It's slow, it typically does not kill people, but it costs a lot of money because you're always having to replace things. And all you need is the soil's going to expand, and it's going to contract. And what this is going to do is just move this material down slope. And why does soil expand? It expands when it freezes, it expands when it gets wet, and it expands when it gets hot. Okay, why does it contract? When it thaws, it contracts. When it dries, it contracts. And when it cools, it contracts. So what happens is that when the soil expands, it's going to move up perpendicular to the Earth's surface. Okay, so all, these little particles are going to be moving up. Notice my line is perpendicular at a 90-degree angle. But you guys, I'm going to pull this back. Remember that blue line. The blue line here, the blue arrow, represents the force of gravity. And look at how this force of gravity works. It's going to pull that, I'll make it in a different color pen. It's going to pull it down towards the center of the Earth. Okay, and then there it is on the surface again. Next time we have a freeze or a wet or a hot period, up it moves, again, perpendicular to the surface of the Earth. And then when it thaws, dries, or cools, down it moves towards the center of the Earth. Okay, so that's the slow down slope movement. And I will be asking you guys to draw these, so make sure you're comfortable with this.